Okie dokie. Break and continue. Hmm. And the point there is that excuse me. Guess we don't care what the order of these are. It's just how it is in the code. So it'll never be the 49 logic and then the 50. In the code it's 50 and then 49. So if we don't put a break after the 50 logic, then the 49 will execute afterwards. Okay. Oh, what am I doing? Oops. Did not do the insertion operator. Cool. Okay. We break to stop from the rest. And then cool. Okay, yeah. Gotcha. Hmm. This is a while, do while, for loop, or switch. So any of the loops or a switch statement to end with execution continuing the next statement afterwards. So if we're in a function and we're running that switch and we find the case and then we run that logic, but we don't want to do fall through and do the rest, we break and then we continue afterwards. Okay. Okay. Yep, preventing fall through. Yep. Yeah, so we're just printing. We're not returning anything. We're just printing whatever the math is. So we do 2 and 3 and then plus. Do the case and then we do the break. Otherwise, if we didn't, let's pretend there were no breaks, it would do all of them. It would do addition, subtraction, multiplication, division. But instead, we do addition and then we want to break. Maybe there's some cases where we want to fall through, but not here. Like if it's this value, we want this to happen and the next one because it's just a cascade. Maybe you're beyond the point of no return for some value. Like gravity, maybe. Like we want something specifically to happen for this gravity, but we also want it because it's going to increase to go and do this next thing afterwards. Yep. Yeah, we already saw that. to end the case. Okay. Break can end the loop early. Okay, so we're saying sum 0. And then we're doing a loop. Counting. Looks like from 0 to 9. So there are 10 different things. The 0 all the way through the 9. So 10 different things. Incrementing. What we're doing, prompting the user, getting input, storing it. I can enter. Seems that, so if they enter 0 yep. So if they enter 0, we break and go to the next thing. Otherwise, sum is what it is plus that. So if they enter 6, we get 6. Sum started as 0, now sum is 6. And if they enter 7, then they enter 7, and the sum is now 6 plus 7, and they go on. But if they ever put in 0, the loop will exit. So up to 10 numbers, because it'll go through 10 loops, 10 iterations, and it will sum them all as numbers get added. If the user enters 0, it instead gives the sum, well, it gives the sum regardless, but it gives the sum prematurely. So we can say 5, 2, 1, so we have 8, but then you put in 0, or 0 to exit, gotcha. 8. So I could break a loop. How would I want to break a loop? Oh, so we could have like, I guess you could have an infinite loop and the loop would be dialogue. So it wouldn't be for in this case, it would be a while, but while player is talking, or while dialogue choice is not whatever. But then if you choose that, then it just doesn't execute again. That wouldn't work. Oh, well, you could have like while character's being aimed at, and you're aiming a gun at a character, and he puts his hands up in the air, and it's while character's being aimed at, keep hands up in the air and shake, and play a dialogue cue, and then still being aimed at, play dialogue cue, keep your hands in the air, etc. But then, if gets shot at, boom, and it checks. Oh, hasn't been shot yet. Okay, we're good. Hasn't been shot yet. Okay, we're good. Oh, got shot. Has been shot at. Break loop. Hands down, run. Or hands down, shoot. Something like that. So breaking out of a loop like this. What else? Oh yeah, I guess that could be. So it could be like, maybe it's a little text-based RPG thing, and you have let's say there's like 4 hours of daytime left, or let's say there's some amount of hours of daytime. Okay, whatever. Let's say there's 16 hours of daytime and then 8 hours of nighttime. And let's say the day's broken out into 4 different 4-hour chunks for daytime. So you can do 4 different things during the day. And let's just say they always, yeah, that's how it is. So you pick an action for each 4-hour period. So there'd be a loop from 0 to 0 is less than 3, or 0 is less than 4, so 0, 1, 2, and 3, or 0 through 3, so 0, 1, 2, 3. And for each one of them, you say what happens. And then something happens. But if you choose instead, so whenever you type in the answer, you choose what happens, and then maybe there's a switch or something else, an if statement, and then it determines what happens. But if you choose go to bed early, it breaks from the loop. Excuse me. So we could have, excuse me, int current day action. And yeah, so we'll just do it. It's an int. There's different actions. Let's say there are actions. Action options are 0 to 3 through 3. Okay, while current day action is less than total day actions, and then current day action, and then we'll also have total day actions, and it is 3. Cool. Okay, that works. Cool. So what we do is we'll have just a standard, let's just get a standard string. So we'll do need input and output for day option, or for day choices, for day outcomes, and then string need standard string for choices. Okay, so we could do a standard string day action, and then we could do standard getLine, standard character output, and then pass it standard white space to avoid white spaces, triggering it prematurely and ending it. So we get everything in this one line instead of it being space something else, and then that something else gets stored in the buffer and put somewhere else. We want to extract the whole line to the standard string, not one word. And then we'll do day action. Okay. And so we'll say enter your, or let's see, what do you do during for action, current day action of the day. Okay, we extract it, and then we say if day action, day action or we'll say, yeah, sure. So if day action is go to sleep early, then player sleeps through rest of day, break. Otherwise, player chose to day action. And we can put in a period there. Okay. And then afterwards, Day has ended. For action 0, we're gonna say catch, cook, and eat fish. So I chose to catch, cook, and eat fish. No, okay. What do we do for the next action? We will chop wood. We will eat food, and then sleep early. Player sleeps the rest of the day. Day has ended. But instead, if I had just done sleep early, it breaks straight away. Boom. Instead of continually going through the rest of the loop. Okie dokus. See if I can digest this and why this is important. So we don't want to return here. Oh yeah, it needs to be a value. So we just return 3. We just say sleep early. It says this and then returns and ends. I want to get out. I want to exit this loop and continue to the next thing without exiting the entire function. That's when we use break. Cool. And it works just like it would for a switch, where we break out of a case, or not even break out of the case, just break out of the switch. We do this. Here's the case we satisfy. Here's that matches the switch expression. Here's the shit we want to do. Break to get out of the rest of the cases and the rest of the logic to avoid fall through probably. Okay. Oof. Yep. Also a common way to get out of an intentional infinite loop, meaning an intentional infinite loop like the game continually prompts you to type in these hacking codes until you enter the right code. Or, let's say, instead of having to enter something, you have to click something, so there's some sort of mouse input, and then while clicked location is not clue or whatever, like you have to click the next clue in order or something, or you have to click let's see, like the game prompts you to click something or to do something, and then you click something else and it reprompts you until you finally click that one thing. So it'll constantly ask you, let's see, 0 to exit or any other integer to continue. So while true, so this is true, you enter a number, and then let's say you entered 4. That's not 0. We don't break, so we continue. 4, 5, 8, 6. Finally, you enter the right answer. So for something where you have to choose the right answer, like maybe what do you do in a fucking Pokemon battle? Well, I guess we wouldn't have a way of getting out. You would have to choose one of those options. So we wouldn't need that there. Or maybe the break would be that flee, and then you exit that way instead of attacking or swapping or using an item. Excuse me. So we can put in 5, 3, 0. Now you're good. Break versus return. Seems like the main difference is that return exits with the return value, that except for voids where there is no return value, because it's not a value returning function, so you don't need a value, you don't need to return a value, you can just return and it ends the function. It's a way of getting out of the function. Yeah, it gets out of the function. Not only does it break whatever you're in, it leaves the loop, it leaves the for loop, the while loop, the do while loop, the switch case, or the switch statement. It also leaves the entire function. So if I had a function with a for loop in it, and I return, the whole function ends instead of just breaking. Yep, entire function that the loop is within. Break and return. Break statement terminates the switch or loop. I wonder what these cases are. New programmers sometimes have trouble understanding the difference. Is it just that someone doesn't learn and then says something and then is incorrect? Or that people ask the questions? Because it sounds like, unless someone happens to stumble upon break and return, they would be told the difference. So they wouldn't have trouble understanding the difference. Just like, I don't know, if someone It seems like in programming you wouldn't naturally stumble upon break and return. Like in like speaking Spanish, you might stumble upon a different word. It seems like in programming you would have read the documentation or learned from somebody or had a class or something like that, and you would have been explicitly taught everything that you type. You're not going to randomly type in some word and then hope that it works. It seems like that's the worst. That's not a good way of learning. I mean, maybe you could fuck around and just type in standard colon colon. What do we have in the standard library, at least within the libraries that I have included so far, IOStream? Or do lowercase bracket and then type in some letters and see what else, what exactly in the standard library you could include and what you could get functionality from. So the break terminates the switch or loop, and execution continues after, whereas return does the same thing, but it's not the same thing, I guess. It's terminating the entire function, and as a side effect, it terminates, well, not necessarily as a side effect, but and as part of that action / process, naturally, you abort the function, or you abort any loop or switch case, or switch statement rather, that you are inside. Okay. KO. So if you enter B, you will break, and then it will end and output this. We broke out. But if you instead return, you will simply see return 1. So the return value. Either you return 0 for when the entire thing completes, or you return 1 for when you have returned early. Okay. Yep. So if we break, the subsequent shit is still going to occur. If we return, it will not. Break or return. Cool. B to break or R to return. Okie dokus. Is there a time where I might want to actually do that? I mean, you could have a function that's like, you could have a function that is solving one puzzle, and there's a loop, and it prompts you to click within, like, let's say you pick up this little puzzle thing, and you're attempting to solve it, and you have to click some things, and there are different pieces of logic within this while statement, and the while statement is while puzzle is unsolved. So maybe we have a variable, and we call it's a boolean, and it's called puzzle unsolved or puzzle solved, and then while not puzzle solved, prompt the user to click one of these things or type a certain thing or something like that. But then we could have maybe a return to put the puzzle down. So put puzzle down, and then it returns and then enters, or like to stop solving the puzzle. And then, so the only way to get out of the loop is to break out of the loop. That's the only way. Keeps going. So if you get the right choice, you break out of it. You found the proper clue. But if you instead choose, maybe just guessing a number, guessing 0 through 10, and let's see, or guessing 0 through 15 million, okay, and one of those numbers is correct, and it's from 0 to 15 million. But if you type in -1, then you put the puzzle down. So maybe it's guess a number between 0 and 15 million, or enter -1 to put the puzzle down. And you type -1, and then it returns, and then it says player put the puzzle down, and then returns, and then extra shit continues going on. Maybe it prompts you, what are you going to do the rest of the day after you try to do the puzzle, or what's next, or whatever. But if you were solving the puzzle and you instead typed in 12,268,444, then instead you solved the right puzzle. You solved it. Break, and then in that same function, it goes to the next piece of the puzzle, and then I don't know, something else happens. So when you want to continue the functionality in the function, we break out of something. But when we want to end the entire function, which we may, and return early, then we return. Okay. Continue. End the current. Oh, so break, instead of stopping the loop, you continue to the next one. So we could say, like, maybe there's a moldy apple or something, and you do, is the apple good? Choose yes or no, and if you do yes, then it adds and says, okay, next apple, next apple, next apple, whatever. Or you could do, excuse me, no, the apple is bad, and it will subtract 1 from total apples now, or subtract 1 from total apples. Instead of it being 10 apples that you're counting, now it's only 9, and then you continue. So you don't add this one, the apple, you don't count it, so you toss it away, and then you continue on to the next loop, instead of it adding on the proper way. And then you don't add, or something like that. Okay. So from 0 to 9, so 10 iterations. If the number is divisible by 4, skip this iteration. So we have 0, 1, 2, 3. So 4 iterations have happened. And on that 5th iteration, where the number is now 4, then we continue. And we instead don't print it. So we would say 0, 1, 2, 3. And then you would see 5, because 4 would be continued and not reported. So 0, 1, 2, 3, 5, 6, 7, 9. Continue statements. When would we want to continue? I feel like I've seen it before. There's got to be something valuable there. I just can't think of it just yet. Continue, where we end this iteration of the loop. Continue to the next iteration of the loop. Oh, maybe there's a random chance. So, like, if we did that Matryoshka doll thing earlier, and then we toss one grenade, toss one, and then it does the 5 explosions. Well, maybe there's a 25% chance that one of those is a dud. And then, if it's a dud, then it prints whatever dud instead of the next stuff and continue. But, I mean, we really would just say if dud, print dud, else print exploded. So when would we want to continue? Like in this case, if that continue, like here it almost seems like in this case we could just say if remainder 4 is 0, so if it's divisible by 4, do nothing, else print the count. So each time we'd say 0. Is it divisible by 4? Yes. Don't say anything. And then 1. Not divisible by 4. So else. Boom. So the use case here. Maybe you do it when you just don't want anything to happen. Well, Not even necessarily. I guess when you don't want anything to happen, maybe. But you could still do the same thing with an. Anything you could do with a continue statement seems like you could do with an if else statement and a null. So maybe it's for readability's sake. It's like you want a loop to happen and something to occur. But if this happens instead, you continue instead of doing that thing. But you could also just say, if that, do this, else do nothing. Causing the current point of execution to jump to the bottom of the current loop. So it skips the rest of the stuff and goes to the next iteration where we do the post. We do the loop variables change, this guy here. And then we reevaluate the condition. Then boom, go to the next. For a for loop, yep, the end statement will still execute after continue. Cool. So that happens after the end of the loop body. When doing it with a while or a do while loop, oh yeah, because if we're continuing instead of adding something to it, and then we're never adding, we're never hitting that upper limit, like number is 0, while number is less than 10. And then we do some stuff, then we increment number. If we instead continue before we increment number, then number doesn't get incremented, and it never increases, infinite loop. It never hits 10. Okay, do a little brain break.